Yeah, good morning. You're welcome to GMAT class. Today we are going to be looking at some questions on the mensuration. So we are starting with questions on the plane shapes. Now, for those of you that are going to write NECO, this uh, exam coming forth, and these questions that we're going to be treating today is going to be very helpful for you. Now, let us look at the first question we have here that we're going to be looking at. Is a question under plane shapes. Plane shapes. Now let's look at the question. Now, a segment of a circle of diameter 24 centimeter subtends angle 90 degrees at the center. Calculate the area of the segment to the nearest centimeter square. Take pi to be 22/7. Now, we are to calculate the what? The segment. Calculate the area of the segment. We are calculating the area of the segment. All right, now, so this segment now is from a circle. So now what will I do now? Let me draw the circle. Let's draw the circle. This is the circle with center O. Now we have been given the diameter of the circle. The diameter of the circle is 24. Diameter is 24 centimeter. Okay, so now this is the diameter of the circle. Now, diameter of a circle is a line that divides the circle into two equal parts. And also, there's one special thing about diameter. It is the same thing as 2 radii, because now from here, from the center of the circle to the circumference of the circle, we have a radius. So from here to this place is also a radius. So that means 2 radii make a diameter. So I need to get the radius of this circle. So I will have r to be equals to d/2. Now the diameter is 24. So r will be 24/2. And r is 12 centimeter. So the radius of the circle is 12 centimeter. All right, now, so the question is talking about a segment that subtends an angle 90 degrees at the center of the circle. So now let us draw a sector. This is a sector, okay, and this is a chord, and this is a segment. Now, this segment subtends an angle at the center of the circle. So the angle is given to be 90 degrees in the question. Okay, so subtend 90 degrees at the center of the circle. You have to calculate the area of the segments of this circle. So now how do we do that? Now, when you look at the segment, let me clean all this. So let me clean all this. So this is the sector. This is radius. The radius is 12 centimeters. We have done that. Now, what we want to get now is the area of these segments. Now, to get the area of these segments, now out of this area of this sector, you removed the area of the triangle from it, so you'll be left with this. I come again. To get this area, now this is a sector. You take away area of a triangle from the whole sector. What you'll be left with is the segment, the area of the segment. So now I will write area of segment now. Area of segments is going to be area of sector minus area of triangle. Area of the whole sector minus area of the triangle. Okay, so now what I need to know now is what is the formula for area of a sector, the formula for area of a triangle. Now, formula for area of a sector, area of a sector, area of sector, the formula is theta over 360 times pi r squared. Now, this is the formula for area of a sector. Now, area of a triangle is going to be 1 over 2 r squared sine theta. So this is the formula for area of a triangle. Okay, so now to write the formula for area of a segment, so you have theta over 360 times pi r squared minus 1 over 2 r squared sine theta. Okay, so this is going to be the formula for calculating area of a segment. All right, so let's substitute. Now, so that gives us theta is 90. We have 90 over 360 times pi is 22 over 7. 22 over 7 times r. R is 12 centimeter. That's the radius. That is going to be 12 times 12 minus 1 over 2 times 12 times 12, that's 12 squared, sine 90 degrees. Okay, so that's what we have there. So now, let's simplify this. 0 cancels 0. 9 goes there 1. 9 goes there is 4. So that's 1 over 4. 1 over 4. Okay, let's do it like this. 90 goes there 1. 90 goes there is 4. Okay, so we can simplify this. 2 goes here is 2. 2 goes here is 11. Now 2 goes here is 1. 2 goes here is 6. So what we have in the numerator now is now 6 times 12, 7. I hope you are getting that. Now, let's go through it again, how we simplify this. 90 goes there, 1. 90 goes there is 4. So 2 goes in 6 and 12 all over 7 times half. So this will turn to 6 times 12 sine 9. Okay, let's look at this question. Let's look at this question. This is Question under plane shape. Okay. So that is the next question. That's the next question. So let's look at the problem on the board and let's see how we're going to solve that problem. Uh, Now, let's look at the question. Now, the diagonals of rectangle PQRS intersect at O. Now, if length PR equals to 16 centimeter and angle QOR equals to 50 degrees, calculate the dimension of the rectangle. 2, its perimeter, and 3, its area. Okay, so now let's look at this problem. Now, the first thing you should know is that the question is talking about diagonals of a rectangle. Now, let's draw the rectangle. Okay, so we have P, Q, R, S. Now, this is the rectangle. And don't forget, in rectangle angles, the angles are right angles. The four angles are right angle. Now, we have rectangle PQRS. Now, we have two diagonals. These are the diagonals. Okay, they intersect here at O. All right, and in the question we are given that PR is 16. Now, when you look at this now, PR, that should be one of the diagonal. So it should be one of the diagonal. PR is 16. PQR. Now, let me look at the question again. So because it should be the diagonal, it should be the diagonal. PQR, okay, PQR. So PQR, so this is supposed to be R. PQRS, okay, PQRS. All right, so PQRS, you have to follow that order because now what you are giving here, so you should know that they're talking about the diagonal. So the diagonal is PR. PR. So from here to here now is 16 centimeter. This is 16 centimeter. And also in the question we have that angle QOR. Angle QOR is 50 degrees. So this angle here is 50 degrees. Okay. So, you know, all these parameters given will help you now to do the numbering well, as in the arrangement of the alphabets. All right. Okay. So now we have this to be 50 degrees. Now the question is to calculate the dimension of the rectangle. So I want to know the length and the breadth. Now, what's the first thing to do? Now, you need to know that these two diagonals will bisect each other. When we talk about bisection in mathematics, it means you divide something into two equal parts. So if I bisect a line, that means I'm cutting the line into two equal parts. So in this case now, so this line cuts each other into two equal parts. So OP is the same thing as OR, and SO is the same thing as OQ. All right. Now the implication of that is this angle here is going to be base angle of an isosceles triangle because this side and these sides are equal. Hope you get that. Now, since from here to here is the same thing as from here to here, that means triangle ROQ is an isosceles triangle. So if it's an isosceles triangle, that means the bases are equal. So now I can get this. Let me call this place X. This place is also X. So they are equal. So we have 50 degrees plus X equals to 180 degrees. Why? Sum of angle in a triangle is 180 degrees. Sum of angles in a triangle is equals to 180 degrees. So now let's add this together. So we have 50 degrees plus 2x equals to 180 degrees. All right. So you can move this one to this other side. So we have 2x equals to 180 degrees minus 50 degrees. So 2x equals to 130 degrees. So x equals to 130 degrees over 2. And so therefore, x equals to what? 65 degrees. So that means the angle here is 65 and this is also 65. Okay, so problem is half solved. So since we know this place to be 65 degrees, so, and all we want to get now is this side QR and side PQ, which is the length and the breadth. That is the dimension of the triangle, or a rectangle, sorry. So now we want to get this one. Now, so I will consider this triangle. Look at it. In triangle PQR, triangle PQR, when you look at it, is a right angle triangle. It's like this. Okay, so this is right angle. This is Q, this is P, and this is R. Here is 65 degrees. Okay, so now I want to get, and I know this side to be what? 16 centimeter. So this diagonal have been given 16 centimeters, so I can get this using a trigonometrical ratio. So now let's get PQ first. So let's get PQ, which we can represent with the length. That's the length of the rectangle. So let's do that. Okay, so now what's the ratio we are going to use? Now we are looking for opposite. This is the opposite. This adjacent. This is the hypotenuse. So what ratio are we going to use? Opposite and hypotenuse. That's what? That's your so. Opposite and hypotenuse. That's sine. You are making use of sine. So we have sine 65 degrees equals to your opposite L over the hypotenuse. That's 16. Opposite over hypotenuse. So you can cross multiply. You have L equals to 16 sine 65 degrees. And L equals to 16 times. Now let's look for sine 65. So sine 65 is what? That is 0.9063. Okay, so L will now be, so you multiply that with 16. So what do you have? We have 14.5. That's going to be 14.5 centimeter. Okay, 14.5 centimeter. So now let's get the adjacent. That's the breadth. So how do we get that? So we want to get this now. So we connect the breadth with the hypotenuse. The breadth with the hypotenuse, that is the adjacent with the hypotenuse. I will always advise, because you can as well connect the opposite and adjacent together. But suppose your answer here is wrong, there's no how you get the answer here too. So it will be wrong. But it's sure that this one is correct. So it's always good you connect the unknown with the given value, all right, than the one you got. So now, so we are connecting this and this. So don't use this and this. So just to be sure that what you are doing is right. So use this and this. So we are looking at adjacent and hypotenuse. Adjacent and hypotenuse. So that, what ratio are we going to use? Adjacent and hypotenuse. That is your car. Car is what? You are making use of cosine. Cosine. So let me do that here. Okay, cosine. So we have cos 65 equals to adjacent. That's your B here. Adjacent over hypotenuse. That's 16. So B will be equal to 16 cos 65 degrees. Okay, so B equals to 16 times, what's going to be cos, what's the value for cos 65? So that's 0.4226. 0.4226. So B will be, now let's multiply. So times 16. So when you multiply that with 16, you have 6.7619. But let's put that in 2 dp. So that's going to be in centimeter. Okay, so that's what we have for that. So this is the length and this is the breadth. So this is the dimension of this rectangle. So now the next question is to get the perimeter of the rectangle. Perimeter of the rectangle. Now let's write that out. What is the formula for calculating perimeter of a rectangle? That's P equals to 2 open bracket length plus breadth. You know why? Perimeter just means the length here plus the breadth here plus the length here plus the breadth here. So we have two lengths in a rectangle and two breadths. So when you add everything together, we'll be having two lengths, 2L plus 2B. So when you factor out 2, so you'll be having this. Okay, so the perimeter now becomes, what is L? L is 14.5 plus, and the breadth is 6.76. Okay, so that's going to be 2 times, let's add this together. So 14.5 plus 6.76. So you have 21.26. 21.26. So when you multiply that times 2, so you have 42.52. And the unit is going to be in centimeter. So this is going to be the perimeter of the rectangle, right? So now the last part of the question is the area of the rectangle. What is the area of the rectangle? So how do we do this? Now I need to know the formula for finding area of a rectangle, and that's length times breadth. Length times breadth. So area be length times breadth. So area equals to, what's the length? You have gotten the length before. That's 14.5 times the breadth, 6.76. So what will that give us? So that's going 14.5 times 6.76. So that is 98.02 centimeter square. Area is always in unit square. So so that's approximately 98 centimeter square to the nearest whole number. So that is the end of the question. So how will the bank be awarded? Now, for making this statement that this triangle is an isosceles triangle, so there will be a block mark for that, because that means you understand that the property of a rectangle, when you have the two diagonals will bisect each other, and the length here and this will be equal. All right, so once they are equal, the implication is this triangle is going to be an isosceles triangle, and base angle of our isosceles triangle are equal. So now for writing this statement here, we have M1, and then for getting the angle 65, there is an accuracy mark for that. Now, the next thing is to get one of the side, which is the length. Now, for making use of this trigonometrical ratio, so we have M1, all right? So, and for getting the length, we have A1. And don't forget, always remember to put units. For those of you that will be writing external exams, so you have to be very careful whenever you are writing an applied question. So unit is very, very important. There's always a penalty for not putting units. If you don't put units, if you are supposed to score 1 here, so 1 will be taken away from it. So you end up scoring 0 for this answer. So always remember to put units, right? So now to get the second side, which is the breadth of the rectangle. So this is M1 and A1. Okay. So now the next question is to find the perimeter of the rectangle. So for substituting correctly into the formula, and method mark 1, and for getting the answer, A1. All right, so now let's move to the last part of the question, the area of the rectangle. So for substituting correctly M1 and for getting the answer, we have A1. All right, how many marks altogether? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 11 question marks. All right, so that is the solution to the problem. So I want to employ those of you that have not subscribed to this channel. Please try and subscribe, share this video with your friend, and also drop your comments. And if there's any topic you want me to treat, let me know. I've seen a comment now. Someone wants me to treat sword. So probably maybe in the next class, we are going to consider that. All right. Now let us look at another question. All right. Okay. The network went off the other time. So now let's come back to the class. Now let's look at this question. This question is under solid shape. Solid shape. Now let's look at the question. Now a sphere of radius 2 centimeter is of mass 11.2 grams. Find the volume of the sphere. Find the volume of the sphere. Roman numeral 2, the density of the sphere. And Roman numeral 3, the mass of a sphere of the same material but with radius 3 centimeter. All right. So now we want to find, the first thing is to get now the volume of the sphere, which radius is this, and which mass is 11.2 grams. So how do we solve this problem? Now the first thing now is to know the formula for finding volume of a sphere. If I don't know that, I will not be able to go further. All right, so its sphere is just like your orange. Orange is sphere in nature. So the radius is the radius of this sphere is 2 centimeter. So this 2 centimeter. Okay, so now to now get the volume of sphere is 4/3 pi r cube. 4/3 pi r cube. So this is the formula for finding volume of a sphere. Okay, so now let's get the volume for this sphere. So volume now will be 4/3 times pi. Pi is 22 over 7. So we have 22 over 7 times the radius is 2. So we have 2 times 2 times 2. Now let me say this. Anytime you are giving question of this form and the question asks you to use 3.14 or whatever for pi, if you use 22 over 7, your substitution will be wrong. So you will not get mark for correct substitution. So whatever the question gives is what you are supposed to use. So I'm trying to say this, that it's not in all cases that your pi is always 22 over 7. So it is based on what the question gives you. But if the question is silent about it, then you can pick either 22 over 7 or whatever. Okay, so please let's take note of it. That does not mean that in all cases I'll be using 22 over 7. So I will look at the question for whatever is given is what I will substitute. So this is what we call correct substitution. All right, now let's simplify this. So so we multiply everything in the numerator because this is the same thing as 2 over 1, 2 over 1, 2 over 1. So we have 8 times 8 times 4. This is 8 times 4 times 22. So what will that one give us? 8 times 4 times 22. So the answer will be 704 over 3 times 7 times 1 times 1 times 1. That is 21. So if you divide that, your answer will be 33.5238 centimeter cube. So that's what we're going to have. So this is going to be the area. You can correct it to 4SF. That's 33.52 centimeter cube. So that is the volume of the sphere. That's the first part of the question. Now the second part of the question, you have to calculate the mass of the sphere, the mass of this sphere. Now we know that density, we have to calculate the density, the density of the sphere. So density of a sphere is the ratio of the mass to the volume. Okay, ratio of the mass to the volume. So mass over volume is the density of it's going to be the density of this sphere now. So now the density now will be, what is the mass? Mass has been given to be what? 11.2 grams over the volume. So let's use this. It's always advisable you use numbers that are not approximated. Okay, so now we use 33.5238. So when you do that now, this is in centimeter cube anyway. So when you divide, let's divide and see what we have. So that's 11.2 divided by 33.5238. So the answer is going to be 0.334 gram per centimeter cube. Gram per centimeter cube. Okay, so that is going to be the density of the sphere. Now, the last one. Now you have to calculate the mass of a sphere of the same material. Now, if they said they have the same material, that means they have the same density. That's the implication. They have the same density. So, and that sphere now have a radius of 3 centimeters. So now the first thing to do now is to get the volume of the new sphere. So the volume of the new sphere now will be, since this is the formula for finding it, so we have 4/3 times 22/7 times the radius is now 3. So 3 times 3 times 3. So this will have cancelled this. Okay, so that means what we'll be having now for this will be 9 times 4 times 22. So that's 792 over 3/7. So when you divide this by 7, your answer will now become 113.1429 centimeter cube. So this is going to be the volume of the new sphere. So now we want to get the mass of the new sphere. The mass of the new sphere. So what is going to be the mass of the new sphere? So before we do that, if you have not subscribed to this channel, please try and subscribe, and also share this video with your friends. We have density. Density equals to mass over volume. Density is mass over volume. Now the density, because it's of the same material, so the density is going to be 0.334 gram per centimeter cube, which is equals to mass. We don't know the mass, that's what we're looking for. The volume, we have done that. That is 113.142. Okay, so from here, 29. So we can cross multiply. So we have mass to be equals to 0.334 times 113.1429. All right, so from here we have the mass to be equals to, so let's multiply. So this times 0.334. So the result will be 37.79 grams. 37.79 grams. So that's going to be the answer to this problem. All right, now let's stop here. So I want to believe you have learned one or two things. Now for those of you that will be writing this NECO, I think this class should be very helpful to you. So, and don't forget, let me award marks here so that you know how the mark will be awarded if this question is asked in your exam. Now, see, for substituting correctly, just like I said, substituting correctly, not just substituting, you substituted correctly. The pi that is given in the question is what you use. There will be a method mark, 1 for substituting correctly. And for simplifying down until you have this, we have M1. That's for that simplification. And for getting your answer, we have A1. Now, if no level of significance is given in the question, always express your answer in 4SF. So that is more reliable. So after writing it, so you can bring it down to 4SF. Okay, so now let's look at the second part of the question. So now for substituting correctly into this formula, we have M1. You see, there is one thing you need to know. Even if this answer is wrong, you have gotten an answer here. Suppose this answer is wrong. If you pick this answer and you substitute here correctly, you are going to get this mark. Now, what will happen now is that this answer you will not be able